I'm starting from the first question. A split ring commutator is used in a simple DC motor. It reverses the current in the coil. How often does it reverse the current? Now, so this is the first question. The split ring commutator is that the part of it, if I recall, for every point here, that is a north pole and a south pole, and this is a this is called a split ring commutator. Look, this is the split ring commutator, and it is a half ring. Split ring commutator is a half ring. So how often does it reverse the current? Actually, the split ring commutator, if you remember the theory, split ring commutator reverses the direction of current after every half cycle. Split ring commutator reverses the direction of current after every half cycle, after every half turn. So when the gap is aligned, so the answer would be B. Now, you people can answer me on chat also, and you people can answer me on mic also, but you people have to answer so that we have a discussion. The diagram shows a simple DC motor. The switch is closed and the coil rotates. Which change makes the coil rotate in the opposite direction? He wants to reverse the direction. And at a faster rate. Increase the current. Okay, A. Okay, one answer suggesting A. If I increase the current, okay, two people are saying A. If I increase the current, the coil will move faster. Increase that, but how I will reverse the direction? How I will rotate the coil in opposite direction if I do not, if I just increase the current and increase the number of turns. So there is a confusion in option A. Okay. Now you say B. One student is saying A, B. Okay. One answer is, sorry, option is there. We should not reverse both of them, because if we reverse, option B is not looking fine to me, because if I reverse both current, if I reverse current and magnetic field both, it won't help me. Answer is looking to be D. Increase the magnetic field and increase the current. Reverse the magnetic field and increase the current. That looks fine, because if I reverse the magnetic field, I make it south and I make it north. The magnetic field direction will be reversed, and reverse the magnetic field and increase the current will make it faster. So that looks fine. The diagram shows a wire PQ between the north pole and the south pole of a magnet. There is a current in the wire in the direction of the arrow. Okay, the current is in the direction of the arrow. Magnetic field is north to south. What is the direction of the force? Remember that it's Fleming's left-hand rule. It is Fleming's left-hand rule. And when you apply Fleming's left-hand rule, the force never takes the direction of the field and never take the direction of current. So two arrows are locked. Force either has to out of the page or into the page. C and D are not possible. Force never takes the direction of current. It never takes the direction of the magnetic field. So put your left hand rule. So give your suggestion A or B. A. Two people are, no, sorry, one answer is A, into the page. B. When I am putting the left hand rule, I'm also getting in the page. You have to put the left hand rule. Current is to the right. Magnetic field is downward. So it's coming into the page. This is electromagnetic induction. So I leave this question. This is also electromagnetic induction. P and Q represent two parallel straight wires carrying currents into the plane of the paper. P and Q exert a force on each other. Which arrow shows the force on Q? Like current, they both are in the same direction. Like currents attract each other. If like currents attract each other, so which arrow shows the force on Q? So if the force is considered, it should be D because it's a case of attraction. Good. The diagram shows a simple DC motor. What is the part labeled Q? It's a memory. Look at the diagram and tell me what the labeled part tells us. A. Split ring commutator. Is it a split ring commutator? Okay. It is a split ring commutator. The diagram shows the magnetic field around wire X, which carries a current into the paper. You have to put your right hand rule on this cross. Cross is in the page. The arrows are there. Which arrows on the field line show the direction of the force on the North Pole? Now see this number 9. This is the arrow. This is north. This is south. Magnetic systems do not apply force on charges. So I have cancelled C and D. Okay, one answer is suggested A. Other people, the arrows on the field lines show the direction of the force on a north pole or on a south pole. Please remember to give the quiz today, the people for whom I have allotted a quiz for today. So please remember to perform the quiz, because by end of November, or by some people have mocks next month, some people have mocks in December. So please remember to do that. Okay, very good. Achha, now I think that we should say that it's a North Pole. Na? This is the North Pole. The arrowhead is always the North Pole. So arrows on the field lines show the direction on the North Pole. This question is repeating. Now look at this question. A beam of alpha particles are positively charged particles. Alpha particles are positive particles. When they are going to the right, current is also to the right. Magnetic field is downward. So you have the direction of current. You have the direction of the magnetic field. Force, left-hand rule, never takes the direction of current and field. So down the page is not possible. Up the page is not possible, because they're already taken by the field, not to south. Now either it is B or C. into the page, if you put your left hand rule, which device uses the force experienced by a current in a magnetic field? Now, these are the two questions. You people have to do these two questions. I'm just coming. Please do these two questions. Current in a magnetic field. So loudspeaker can be an option. What about 12? 12 answer C and B. 12 answer for 12 is B. C loudspeaker. Huh? Answer for 12 is loudspeaker. Answer for 13, the diagram shows a current carrying wire in a horizontal magnetic field, which arrow shows the direction of the force experienced by the wire. What you people suggest for 13? 13 you people have suggested C and B. Achha. For second one is B. Current is coming out of the page. Magnetic field is in this direction. Two long parallel conductors carrying current lie in a horizontal plane. The two conductors attract each other. So remember this concept: when two wires are carrying current and you find them attracting each other, it means that two currents are in the same direction. The two currents must be in the same direction. Okay, one answer I got is A. Other people should also give their answer. One student gave the answer A. B. Why B? Unlike currents repel each other. Like currents attract each other. Unlike currents repel each other. Unlike currents repel each other. A wire hangs between the poles of a magnet. When there is a current in the wire, in which direction does the wire move? Now see this question. Today class is 15-minute extended because of the Isha break. So please remember that the class, I forgot to write in the message. Answer is suggested to be B. Answer is A. Put the left hand rule. You need to find the force. Magnetic field is not to south, current is downward. So I'm getting force out. I'm getting force in direction of A. Look at the direction. I'm getting answer in terms of A. Now look at this. A current carrying wire lies between the poles of two magnets as shown. Magnetic field is north to south. Current is downward. Now suggest, put the left hand rule. B. One answer I got is B. So put your left hand rule. Current is going downward. Magnetic field is left to right. So force is out of the page. Now look at this question. The diagram shows a wire placed between two magnetic poles of equal strength. A current passes through the wire in the direction shown. The current causes a downward force. Now, this is a bit tricky question because the force is given. This time, the direction of the force is given. Direction of current is also given. Direction of force is given. Direction of, so you have to hit and trial and error. So which fits here? First, I try option B. Now, in option B, force is coming upward. Current is towards us. North is not possible. South is also not possible. So C and D are wrong. So we have to select A and B out of A and B. Please give your selection. Give your answer. Answer is A. Because if I try B, if I put my left hand and on B option, the force is coming out of the pay. Force is coming upward. Now look at this question. two straight electrical conductors are parallel to one another. Each carries a current, one into the plane and one out of the plane. So one is out of the plane and one is into the plane. Which diagram shows the magnet? Remember then when currents are in opposite direction, when currents are in opposite direction, they produce magnetic field in opposite direction. They won't merge. They can't merge. They have to be separated. Unlike currents repel. That's right. Unlike current repel. So option D is wrong. That's fine. But what about A, B, C? You have to check the right-hand rule now. B is coming wrong. C, acha. C is showing repulsion, but check dot and cross. C is coming right. C is meeting the conditions. No, A won't be there. Na? A doesn't show repulsion. When currents are unlike, they have to show repulsion. Now, number 19. So, number 19, a current carrying wire is placed between the poles of a magnet. What is the direction of the force on the wire due to the current? Magnetic field is north to south. And let me show the current. Its current is coming like this. This is current. So current is coming towards us. A, because current is, force is coming upward. Right, A is the answer. Right, good. Now you people try these two questions. There's a short break for namaz and we will continue it after the namaz. If any one of you want to say namaz, you can also do that. There's a break of around 10 minutes and we are continuing after that. So now tell me what answer do you people make suggested for number 20? Cylinder should be of iron or steel. Magnet should be steel, but cylinder should be iron because it's a temporary magnet. C is suggested. Why copper? Copper is not a magnetic material. Shielding resin. D is better. D makes sense. D makes sense because the magnet should be a permanent magnet and cylinder should be a temporary magnet. Iron core. Two, sorry. Two long straight wires hang vertically close to each other. The wires carry currents in opposite direction, dot and cross. Which diagram shows the magnetic field pattern around the wire? One is dot, one is cross. Unlike currents attract each other or repel each other. Unlike currents repel each other. So it should be a repulsion case. So C and A are out of discussion. B and D. Cross means in the page. B makes sense. Everyone should contribute to the answers because it's a MCQ practice, not solution. The diagram shows a beam of electrons. When beam of electron is moving to the right, current should be shown to the left. Magnetic field is in the page. Let me make crosses here. So when the charged particle enters in the field C, Acha, you say the answer is C. One student says the answer is C towards the bottom of the page. So if you put the Fleming's left-hand rule, force is coming like this towards the bottom of the page. Now, see this 23. Are you talking about C, Maha, or D? Or are you talking about 23? Hamad, your answer for 23? A rectangular coil is placed between the poles of a magnet. Acha, previous one is C. Fine. Previous one was C, right? At number 23, a rectangular coil is placed between the poles of a magnet. A current passes through the coil as shown. Now current is moving like this. Magnetic field is right to left. Sorry, left to right. So if I find it from the Fleming's left-hand rule, here the force will be upward. Here the force will be downward. It's like this. So I'm getting the answer D. Look at the answers. Answer is D. Right, good. Now look at this question. Look at this question 24. Each of the diagrams show a cross section through two parallel current carrying conductor. Which diagram shows the shape of the magnetic field pattern and the direction of the forces on the two conductor? Like currents attract each other, unlike currents repel. Like currents attract each other. Okay, Anaya says C. C, unlike currents repel. What other people says? One answer I got 24 for C. C. Which single coil motor has the largest turning effect? Now solve this one. I got one answer D, but what about other people? Single coil motor has the largest turning effect. Current in the coil 10, highest current. Number of turns highest 200. Iron core, yes. D is the right answer. Two parallel wires carry currents. Read this question. Please, everyone should participate. He says current in both wire is reversed. So this is the present situation. So if I reverse the direction of current in both wires, I'm going to reverse the current in both direction. Let me reverse the current. So it will be like this, and it will be like this. So this compass will reverse. This will reverse. And this will also reverse. So all three are reversing. This we have already done. Okay, now do this question for me. Like currents attract each other, unlike currents repel each other. Right. Now this 29. T. What is the cylinder? Why is the cylinder made of soft iron? Because it will enhance the magnetic field, because it will become a magnet and it will support magnetism. It will enhance magnetism. Two parallel wires carry currents in the same direction. Which diagram shows the magnetic field around each wire and the direction of the force on each wire? Now, this is also a similar question. Try this. Like currents attract each other. So option is either A or B. Other people should also answer. Option is A or B. A. One component of a simple DC motor is a split ring commutator. Which metal is used to make the commutator and why is this metal used? Split ring commutator is used to transfer current. It should be a good electrical conductor. It is not a magnetic system. It's a pure conductor for current. Split ring commutator should be a good conductor of electricity. Now, give this good question, give a try. How come C? Because wires in the same direction attract each other. Yes, B is the right answer. So we stop here and we will inshallah continue in our next class. Allah Hafiz.